So we're going to be talking now about simplifying rational expressions. And whenever we talk about a rational expression, we're talking about something that can be written in the form of a fraction. Anything that can be written in the form of a fraction is what we refer to as a rational expression. So here's what we're going to be doing. Whenever we talk about simplifying, we're usually going to be dividing the top and bottom by the same number. Now, if we've got something like, say I've got something like 6/20. Now, when we do something like this, we'd usually just say, oh, I'm dividing the top and bottom by 2, and we're moving on from there. What's really happening, so if I were to just divide the top and bottom by 2, I'd end up with a 3/10, and we'd say, oh, that's our answer, 3/10. What's happening is something a little bit more complex, and it's happening kind of behind the scenes. So here's what we're really doing. We're going to do something that's I want us to show sort of this step when we're going into it. We're going to do something like say, oh, this is 2 times 3 is 6, and 20 is 2 times 2 times 5. I'm just doing a prime factorization here. And then we cancel out our like factors. When we cancel, we're just dividing them by the same thing. What do I have left? I've got a 3 up top, and I've got 2 times 5 down below, so I've got that 3/10. So something very similar happens when I've got a more complex expression. Say I've got something like x plus 1 times x minus 4 over x plus 3 times x minus 4. The same concept applies. When I'm reducing, I'm dividing the top and bottom by the same thing. It doesn't have to be a single term. It can be an entire binomial. So what I would have left here is x plus 1 over x plus 3. Now, I cannot reduce this any further. I know that some folks will look at that and say, oh, I've got an x that's top and bottom. You cannot reduce an added or subtracted term. You're only allowed to reduce multiplied terms. So you're going to reduce your multiplied terms. And the name for that multiplied term is a factor. So the next steps here, we've been, is when we're doing something like this is, of course, to factor it and then reduce. So let's show you what that would look like. So here's more what your overall process is going to look like. You're going to fully factor the numerator and denominator. And then you're going to reduce your like factors. So for example, say we've got something like x squared minus 9 over x squared minus 5x plus 6. When I factor this, x minus 9, or x squared minus 9, this is a difference of squares, so this would just be x plus 3 times x minus 3. If it helps you to take an extra step to do this, this is a simple trinomial, but I'll go ahead and show the work to how to factor that as well. Thinking about factoring that this x squared minus 5x plus 6. 6 happens to be I could do -1 times -6. That would multiply together to be a +6, but that doesn't do that. How about -2 and -3? So this would be x minus 2 and x minus 3. So I'd have x minus 2 times x minus 3. And then I get to reduce my like factors. So I'd be left with x plus 3 over x minus 2. And we're done.